Hello everyone, welcome back to the channel. Today we are going to understand comparable and comparator in Java. So what is comparable? Comparable is an interface which provides natural ordering for the class or the object basically. Let's understand this with an example. See, I have created the employee class. Okay, now this employee class it implements comparable. Okay, so this is how you implement the comparable. So next time if you apply any sorting of the employees, then it will use the natural ordering what you have provided using this comparable interface. So if you want to provide a natural ordering of sort, then you use comparable. Just keep that in mind. It cannot be changed. I mean, you can change it in the code, but once it is deployed with the code, it will remain as it is. It is static basically. Now, I have just added the compare to method. So whenever you implement the comparable interface, okay, so you have to implement this method compare to. Compare to, so basically the caller of the method, if it is compared with the object which is being passed. Okay, so there could be three values. When the caller is less than the passed object, then you get -1. If it is same, you get 0. And if it is greater than the passed object, you get 1. So that's how compare to works. Now let's understand this with this example. See, I've created a static list of employees. So this is the list of employee. Okay, this is the dummy data. Now we'll try to sort this list of employees. Okay, so for sorting, I'll use this sort method. I'll not pass anything, and when I don't pass anything, it will take the natural ordering. And what is the natural ordering? Whatever I have provided in the employee class, and the natural ordering is based on age. So I'm using age for the sorting of my employee. See, I can add more also, but then this is the natural ordering that I have provided right now. So my employee list will be sorted based on age. Let's see the output. See, as you can see, 20, 40, 45, 50, 50. So this is how comparable works. And suppose if I just comment this, you can see what will happen. For no issues, let me run this. Either I got this exception basically because you have sorted, was expecting comparable, but then I didn't find anything. Now say I can also do sorting using Collections.sort. If I do this, if I pass employee list. See, in case of Collections.sort, I get the compilation error. But in case of streams, when I'm using sorted, it didn't give me an error. So this is the difference. And if I just comment this, now this is working fine. This is how comparable works. It is quite straightforward. Now I have defined natural ordering as or based on age. But say suppose there is a requirement that I want to do sorting based on salary. Then how do I do that? Or there could be a combination, right? Say if my age is same, then do salary or by name. There could be multiple custom sort sorting field or sorting order that I need to apply. So for that, we have the option of comparator. So let me first create a comparator class. This is before Java 8, how you would do actually. After Java 8, it has become much more easier. Let's do this. I have to implement this method compare. Okay. So here I define what would be my, I want based on salary. Since my salary is a long, that is why I have to use long.compare. So these are the static methods. Compare is the static method. And then the static method internally calls the comparative method only. Let me show you this. See this. So in this case, it is doing directly. But in case of integer compare, right, you would see that it is calling comparative. As you can see, the first parameter, if it is less than 1, it is -1. If it is equal, then 0. If it is 1. So now I've defined a custom logic. Right, let me try this out. Employee list dot stream dot sorted. Now let me pass this PNP comparator. Let's see the output. See how here you can see now it is based on salary 1000, 2000, 3000, 4000, 3500, and 4000. This is how you can provide. But now, say suppose now this employee comparator is also doing based on salary. But say suppose I want to make it dynamic. So let's make it dynamic. We'll create an enum. Okay. So I have field ID, I have salary, I have age, what else is here? Salary, name. These are the options. Let's try this out. Dot field. We simply use switch actually, which is in this case ID. I will do the this is long actually, right? Long dot compare, one dot get ID, comma O2 dot get ID. Now it is dynamic. So here I can pass ID, salary, age, name, etc. And then based on that, it will do the comparison. If it is ID, get ID, salary, get salary, name, it will do based on name, and age on this age. Now I also need to create a constructor. Right now, I'll pass the constructor. See, based on not ID, let's say salary. Okay, let's run it. So, taken based on salary. This is 1000, 2000, 3000. 500. Now let's take on name. As you can see, ABX, it is sorted by name now. If I do by ID, 1, 2, 3, 4, 5, and age. Now it has become custom. Some logic is being applied. Here I have created the comparator class which implements this comparator interface. But after Java 8, we have this option as well. Now in sorted, the second option, right? Here we can pass the comparator. Now in comparator, there are many default methods which we can use. So here Comparator.comparing, I will directly pass see what it is expecting. It is expecting basically the key on which I need to do the comparison. So in our case, will be like v dot get h dot thing for each. And this is get h. Here I'm not using any comparator class. Here I'm directly passing the method, basically the way it should be executed, or basically the key on which it should be the comparison should happen. So that's the advantage of using comparator.comparing. And I will change it. Okay, I will do it by get name. So as you can see, ABXY is it is still changing. It is changing, right? Based on name. And if I do based on ID, so the same thing which we did using the employee comparator class. Now you can do it directly. You directly pass the lambda function basically. So this is equivalent to, let me show you. If I do new comparator employee, here this is the inner class, and this is what we are replacing by using the comparator to compare. That's the advantage that we get with the comparator. Another advantage that we get with the using this comparing class or the other methods of comparator, we have done by ID. Let me change it to age. Okay, first it will do by age, and then say suppose I say age is same. Yeah, if I say that age is same, say in the case of A and B, age is same, right? Then you do comparison based on the salary. You need to do this change. Now first it will do by age, and if age is same, then it will do by salary. Let's check this out. Okay, so as you can see, when age is same, then it did sorting based on salary. So B got above A in that case. And you can even, this is one thing, and say I want to apply reverse, basically in the descending order. So I can do it easily. Here it will start with 50, when the age is same, then it will do the salary ascending, and then descending age. So this is how it works. So you can easily do ascending and descending using the reverse. This comparing method, and then this this then comparing and reverse. This allows you to do chaining as well. So this is the advantage that you get with comparator.comparing. These are the various methods of comparator class. We'll just go through them one by one. These are very simple. Comparing, you already used it. So we send the comparing and the key basically on which we need to do comparing. And in comparing, this is the overloaded method where we send the comparator. Here we are sending uh, the case insensitive order in case of string. You can even pass comparator.reverse. Just one example, the one which is reversed, right? We can make it overloaded here. We can pass reverse order. It will do the same thing here. As you can see, it is in descending order. What we did with reverse. And then we have comparing int. So comparing int is basically a method provided so that there is no boxing needed, right? And then same for long and double. So just to avoid the boxing basically. And in case of, this is another one, natural order. Okay. For in our case, employees, let's see what would be the natural order. Natural order is on age because here we have kept it as age. Let's change it to salary. Longer compare. Now let's run this. As you can see, we have changed the natural order. The natural order is based on salary, and we have basically done in the descending order. And that is why the output is in this way: 4,000, 3,500, 3,000, 2,000, 3,100. This is the natural ordering. Reverse order we have already seen. Whatever is the comparison logic, and then if you want to reverse that, and nulls first and nulls last. It returns a comparator that treats null as less than non-null values. The null will be first in the order. This is for the ascending order. In the ascending order, null will be first, and then the values. And when we say nulls last, it will be at the last after the values. These are the comparative methods. You can use it in your day-to-day work. Thank you so much.